In problem 16, we are asked to find dy dx by implicit differentiation. Our problem is x equal to secant of 1 over y. We proceed by taking dx on both sides of the equation. What you do to one side of the equation, you do to the other side of the equation. D dx of x is simply 1, and since we need to find dy dx, we apply the chain rule by taking d with respect to dy of secant of y of x times dy dx. This is the chain rule, and you can notice that dy here and here cancels out, and you're back to d dx of this. But by writing it this way, we can isolate out dy dx, which is our answer. So I will call this equation right here equation A. Well, we don't really know how to differentiate secant of 1 over y, but we do know how to differentiate a simpler expression, secant of u. So we know that if we let u equal to 1 over y, we can apply the chain rule and differentiate this expression. We know that by the chain rule, the derivative of secant of 1 over y is simply the derivative of secant of u times the derivative of 1 over y. U is our inside expression. So we have two pieces to work on. The first piece is derivative of secant of u, which by definition is secant of u tan of u. Then we substitute in u equal to 1 over y, and we get derivative of secant of u equal to secant of 1 over y tan 1 over y. The second piece is simpler. Derivative of 1 over y, we use the power rule, so it gives you minus 1 here and minus 2 here, and that's just equal to minus 1 over y squared. Okay, back to the chain rule. It told us that the derivative of secant of 1 over y is equal to the first piece, derivative of secant of u, times the second piece, the derivative of 1 over y. Now that we have this piece right here, this answer, we plug it back in our equation A. And if you recall, equation A on the left side has 1. On the right side, it has derivative of secant of 1 over y times dy dx. I'm just rewriting it. And I will call this big expression here B. We are almost there. You can see that we can isolate dy dx, which is our answer, by dividing both sides by b. So when we divide both sides by b, we get 1 over b on the left side and dy dx. At this point, it's just a matter of algebra. 1 over this big expression of b equal dy dx. Notice that this is a product. You have multiplication here and here. So you can break this big fraction into 3 simpler fractions. 1 over secant, 1 over tan, and 1 over this reciprocal here. If you recall that cosine is the reciprocal of secant, then you can have cosine here. Cotan is the reciprocal of tan, you have cotan here, and this is simply minus y squared. So when you multiply these three together, that's equal to dy dx. That's our answer.